Can you imagine a plate, a solid plate, 40 centimeters thick, that's 400 millimeters. Now imagine that the kind of thickness is being cut verbleif what? On nothing but light. As you know, at FORZA Laser, we specialize in fiber laser technology for metal cutting, and we always bring you the latest updates. And now, here's a major milestone. They've managed to cut 410 millimeters of mild steel. We're living in the era of high power laser. Back in 2004, 20 years ago, a 1,500 watt machine could cost up to $800,000. Today, that same power level might cost only about $40,000. That's 20 times less. Now think back to 2014, 11 years ago. In the industry, a 1.5 by 3 meter area was typically running machines with 500 watts of power. That's what was standard or affordable. Then in 2023, we heard the big news. 60,000 watts, the highest power ever announced. That power level already cuts more than 2 inches thick. And now, last year, 2024 in January, Raycus launched a laser bridge with 120,000 watts. That happened just a few months ago. They managed to cut 30 centimeters, 300 millimeters of mild steel. And just 3 months later, BWT, another Chinese company that also manufactures laser sources, released a new 135,000 watt source. I honestly can't even imagine what that means, but they achieved it. They cut 410 millimeters of mild steel using oxygen. This news came out of Jinan after more than 3 months of collaboration between the company BWT, which manufactures the laser sources, and FS Cut, which makes the cutting heads. Interestingly, both of these companies are Chinese, and in fact, Raycus, the one that launched the 120,000 watt laser in January, is also a Chinese company. That's because a laser source cannot exist without its head in order to perform a cut. Actually, I should also mention that BWT has already launched its new 150,000 watt source, but they can't go for higher powers if the cutting heads don't exist, because the heads themselves are also a complex technology. At high power levels, they generate much more heat, and the level of technology required to control a clean and stable cut at those powers is pretty intense. So the source and the head have to coexist. They must be developed together. And that's why these partnerships are formed. And before we talk about the advantages, let's go over some of the challenges. When we're talking about 12,000, 20,000, 30,000, 40,000, 50,000, even 120,000 watts, there are some very important factors to take into account. First, as power increases, the lenses start to heat up more. Of course, no system is 100% efficient, so part of the light doesn't pass through. It turns into heat. And at these power levels, that heat can cause the lenses to explode easily. That's why temperature control is absolutely mandatory when working at high power. Second, errors become much more dangerous because the amount of sparks and debris increases significantly. The behavior of these high power systems is more complex to manage, especially when cutting a section 400 millimeters thick. You need constant, stable control to get a clean cut. Third, piercing becomes extremely tricky. If you watch the video, you saw the cut starts from the edge. That's because piercing thick material is very difficult. And companies like ours dedicate ourselves to developing and testing those piercing processes so that you, the client, can simply press play and start cutting without any trouble. Another important aspect is the complexity of parameter configuration. I personally like to call this legendary level. Because beyond the usual parameters, cutting speed, pressure, focus, gas type, a whole range of new variables needs to be added when working with high power. At this level, we're now using new nozzles, not just the standard single or double. There are now special nozzles designed to direct the assist gas in completely different ways. And speaking of gas, now we're also seeing the use of mixed gases. Before, we only ever heard about nitrogen, oxygen, or air. That was it. But now terms like gas mix or mixed gas are becoming more common, and this is a completely new development. In fact, we'll be releasing a full FORZA Laser video explaining how gas mix works. So make sure to subscribe so you don't miss it when it drops. Now, in order to explain the advantages of high power, I want to start by highlighting one of its limitations: geometric and thermal restrictions. Let me give you a real-world example. One of our clients has a 3,000 watt machine, and yes, it can cut 3/4 inch steel, and for simple shapes, like the one in the top left of the screen, it performs well. But when it comes to small figures, tight curves, or designs with many close details, it starts to struggle. Why? Because we're already working at the power limit of what 3,000 watts can do on 3-inch mild steel. At that point, the material heats up too much, and you can't make small or complex cuts without melting or distorting the material. So we need to understand something clearly. When we talk about cutting at the limit, it means you can cut straight lines, squares, big circles, but not small features that concentrate heat in one spot. That's where the problems begin. It's common to hear people say things like, "Diego, you know what? I'm going to wait 3 years. Laser prices will probably drop." Maybe they will, but if you wait, you'll miss the opportunity to use a technology that's already affordable, a technology that no longer costs hundreds of thousands or millions, and that you can actually buy today and start using. You can recover your investment quickly because the industry already needs this level of performance. Now, let's talk about productivity gains. When you move from 6,000 watts to 20,000 watts, you can get up to 96% more productivity. Literally, you could almost double your output from the same material plate. So, for example, if you're currently spending 12 hours cutting, with 20,000 watts, that time drops to about 6 hours. The same principle applies when moving from 20,000 watts to 30,000 watts. Here's a real case. Cutting a 2-inch plate, we reached up to 61% more productivity just by using a 30,000 watt machine. Obviously, speeds can still look relatively slow, but when it comes to total time saved, it matters. It's not the same spending 10 hours as spending 5 or 6. That's a significant difference. Here, I've got a small chart to give you a general idea of how it works when cutting hardox, a type of mild steel using 20,000 watts, 30,000 watts, and 40,000 watts. Across different thicknesses, you'll always see higher cutting speeds as the power increases, and that's one of the biggest advantages of high power lasers. Now, let's go back to the type of gas, because that also plays a big role in cutting performance. It's not the same to have a 30,000 watt machine using oxygen versus air. Remember, oxygen is used for hot cutting. Air, nitrogen, or mixed gas are used for cold cutting. Cold cutting can go much faster, and in terms of productivity, up to 5 times more if you're working with air instead of oxygen. In fact, here we have a small chart showing different use cases of mixed gas, air, and oxygen. When cutting 30 millimeters, I get 84% more productivity. If I cut 20 millimeters, I get 237% more. If I cut 12 millimeters, I get 519% more productivity. So yes, you can be up to 5 times faster if you're cutting with air. And with that, I wrap up. If your budget allows it, the short conclusion is increase your power if you're working with thick materials. We always tell our clients, if you have the budget, more power is never wasted. It will allow you to cut faster, make smaller and more detailed shapes because the material won't overheat, and of course, in general terms, you'll be more productive and recover your investment much faster. And lastly, it's important to point out that here at FORZA Laser, we're not directly tied to any specific brand. Yes, it's true, almost 90% of our current machines are equipped with maxotonic sources, but we're not limited to that. This is a perfect example. If a client comes to us and needs 120,000, 100,000, or 135,000 watts, we'll use BWT, a company that's at the forefront of laser technology, and will integrate their sources into our machines. Thank you so much for joining us in this video, and I'll see you next time with another update or news from the world of laser technology. Bye-bye!